So hi guys, I'm Shyam, and in this session we will benchmark a video analytics pipeline on a production cloud that will be AWS. So in this session we will first use AWS CLI to manage our AWS services, which and AWS CLI is an application developed by AWS to manage AWS resources and services from the terminal. Second would be setting AWS authentication so that we can access our resources. And then we will deploy a Lambda function with container image. So earlier you guys were deploying AWS Lambda function with zip. So the second method which is rapidly growing is deploying function using container images. We are going to use that. And the last would be to analyze the execution time of the workload which we deploy with AWS X-Ray. So just brushing up the video analytics pipeline, which Dmitrii mentioned. So the first function would be video streaming function. And this function will have the MP4 or video file embedded inside the container. And this function will create, it will transfer the video file to a S3 bucket and then forward the URL of the S3 bucket to the decoding function, which will then fetch the video from the S3 bucket from the URL. And then this function will split that video into a number of frames. And that number of frames will then again be pushed to a S3 bucket. And then the URLs of those files will be transferred to the object recognition function, which will fetch a URL and then perform object recognition on it, and then send back the response to the decode function, which will then send back the response to the video streaming function, and then we will get the response. So basically this will upload a video, this will download a video, split into frames, and then invoke n number of object recognition functions per frame. I mean one function per frame. So now moving on to the demo. So can you guys please go to the binder URL and open the uh, binder for this session? I can paste it in the Zoom chat if you want to.
Shyam, can you increase the font, please?
Of the slides?
Of the terminal.
No, I mean, terminal is not needed. I will also go to the binder.
Shyam, I think you can just say it.
Okay. So if binder is ready for you guys, then please let me know so that we can proceed.
I think you can go ahead. There are quite a few people who already did it.
Okay, so moving on. First step would be to install the dependencies. So the first dependency is AWS CLI as mentioned, and second is GQ for parsing the CLI output JSON. So I will run that step. So after that, next step would be to set up AWS environment variables. So you guys already have this. Just copy and paste AWS access key, secret key, and account number in this cell, and then press Shift plus Enter. And please stop me if the bind is not ready for you or you missed something. So assuming everybody has completed these two steps, we'll move on to setting up identifiers. So as I mentioned, we need to upload our objects to S3 bucket. So now we need to create that bucket, and in order to create unique buckets for every one of us, we'll create a hash. So for creating the hash, just enter something here. Your name would be preferred to make it unique, or you can write anything else also. So now, as you can see, the output of this cell contains the hash, unique hash for me, and we will use this hash for the rest of the tutorial to create unique resources on AWS. So assuming hash is ready, we will create one S3 bucket using this command, create bucket command, and the parameters required will be bucket name, which will be the hash for us, and location constraint. So creating the bucket. So the output of this will contain the bucket URL, and we will not be able to access it without the credentials. And in case you run into some errors due to hash classes, you can just rerun the previous step and then the hashing step with some different string, and then create the bucket with the new hash. So assuming bucket is ready for everyone, I will move ahead. So now, in order to create the Lambda function, we first need to create something known as Lambda role. So role is similar to a virtual user for AWS. So let's say I open my AWS console and I have my account. So I'm logging in using some credentials and I am a user of that AWS account. So let's say you want to make some service Lambda function as a user. So then we need to create a role. So role will be similar to a virtual user for AWS. It is an identity, virtual identity for some service like I have for myself. So in order to create a role, we have a function called create role, which takes the role name and the policy document, which is the JSON which I am showing here as input. And then it will export the role ARN. ARN is Amazon resource name. This is unique for every AWS resource which anyone in the world creates. So we'll export that for later use and just run this cell. So in this cell, as you can see, this is the ARN and this is the Lambda role variable which got exported. So next step would be to create a policy. So policy basically contains the permissions, which list of permissions which are to be allowed. So let's say for our Lambda function, since we are using, since the first function will be invoking the second function, so we need to give the first function permission to invoke the second function. So this is the permission stating Lambda invoke function. So the streaming function will have the permission to invoke function, and which function will have to be listed in this resource. So currently it's a star, means any function will be able to invoke any function. And similarly, there are other permissions like S3 access and then X-ray and some other accesses. So now we'll create a policy using the JSON which I showed in the previous slide. So we'll go and run the cell for creating policy. Okay, so policy is created now, and we have Amazon resource name for that policy. So now we have a policy listing all the permissions, and we have a role stating that is a virtual identity for AWS. Now we need to link those two so that anybody who assumes this role can have this permissions listed in a policy. So let's say if I attach this role to somebody else, and since these policy and role are linked, that guy or that service will be able to access everything mentioned in the policy document. So now I will just link those two using attached role policy command. So this has not written anything, and our role and policy are linked. And I mean, since there's no error, no output is there. So now the first step of creating function. So we will create a Lambda function, and this is a huge command. So I'll explain all the parameters because they are important. So the create function command takes many parameters. So the parameters which we will be using are function name, which is the recognition function, followed by the unique hash which we created. And second parameter is package type, which is image. So if you are uploading a zip, then you have to mention zip here. And since this is an image, we also need to have the image URI, which is this. So we have uploaded the images already to the AWS account, which we all are using. Otherwise, you have to upload an image first and then use its URI. The next parameter is role. So the role which we exported is to be filled here. Then next would be a timeout. So timeout is in seconds. So if the function runs for more than 120 seconds, it will be automatically terminated by AWS. So the next parameter is memory size, which is in MBs. So our function will have 4096, that is 4 GB of memory. And since we have created unique buckets, we also need to state which bucket is to be accessed by that function for uploading or downloading objects. So here we are providing that bucket name as environment variable. And then we also need to look at the traces. So there's tracing config, and the last parameter is publish. So if you don't write publish, the Lambda function will be created but won't be accessible. In order to make it accessible immediately, we have to write publish. And in case you run into some errors here, you can just delete the function and try again. So I will create the function now. So as you can see, this is the parameters which I gave, and the function is currently creating. So it will be created in 10 seconds or so. So for creating two streaming function and object recognition function, we have a convenient script which we will run, and this script has two commands very similar to this, except the image URI and function name are different. So we'll create those two functions. So this one is a bit long because it waits. So we will have to wait for around 30 seconds to finish this. So I can take some questions if you have any at this moment. Okay, so since there are no more questions, I will invoke the function using the invoke command, and it requires the name of the function which we want to invoke, followed by the payload which we want to give. So there are two parameters. One is name and transfer type, and transfer type contains S3 because we are using S3 buckets as the intermediate storage. So we'll just execute the function. And it also contains a response.json, and this file will contain the response of the function, which uh, response of the streaming function. So the function executed with status code success, and then we can see the list of objects being detected. So as you can see, there's a cab or passenger car, coach, carriage, and like this. So this is the image which is being recognized, and as you can see, it has some cars and cabs and vehicles. So moving on. So so now we'll just look at the trace of the function. So this is a graph prepared by AWS, and as you can see, the streaming function invoked the decoder function, which in turn invoked the recognition function. Now we'll go to AWS console and then watch these traces. If you go to a AWS console in the Lambda section, you have the list of functions. So I'll open that and then go to my function, the streaming one, because that is the first function. So now from here, you have to go to monitor, and then this contains metrics, logs, and traces. So we will go to the traces one. As you can see, the graph is also prepared here, and then we can go to the traces, which is here. So as you can see, the graph is prepared by AWS, which I showed you earlier, and there are traces. So now analyzing the traces, what we can see is the streaming function totally took 32 seconds. And out of those 32 seconds, 100 seconds were initialization, and other 100 milliseconds were initialization, and 33 seconds for invocation. And out of those 33 seconds, the second function, which was the decoder function, took 33 seconds, which as you can see here also. And then similarly, decode function fetch the video file and then processed and then split it into frames and then uploaded the frames. And then these frames go to the recognition function, which takes 28 seconds, as you can see here, or here also. And then these 28 seconds out of this, 55 milliseconds were used to fetch the object, and other total invocation took around 2 seconds. But initialization took 15 seconds. So why is that? So the first function initialization took only 100 milliseconds, the second one 1 second, and the third one 15 seconds. So this was because these three functions are different, and these last two functions are written in Python, which is definitely slower. So, and the first one is in Go. So this is why we got such a huge difference. And another field to note is so out of these 100 milliseconds, we don't know the breakdown. So in total, AWS took 100 milliseconds to start our function. But what if we need to optimize this? So instead of 100 milliseconds or 1 second, or let's say 15 seconds here, we want to improve upon this fields, but we don't have the traces. The complete initialization trace is a black box for us. So if you want to dig deeper, then we can look at vHive traces, because vHive is a full stack application to deploy and research on serverless functions. So moving on, the takeaways from this section would be AWS Lambda supports function deployment with container images. And this is a huge advantage because earlier, because let's say you have a container, you can test it on your machine or upload the same container to Azure or to GCP, and you will have the same function running. You only have to code once and it will run anywhere. And the next would be AWS uses roles and policies to set up boundaries for a function. So let's say if I have some function and one goes rogue, but if the boundaries are defined properly, then the risk would be much less. So one idea to improve upon would be only to list the resources which we want to allow here instead of a star. Currently, anybody will be able to access any function, but let's say we mention the resource properly, only that function will be allowed. And third is AWS X-Ray. So AWS X-Ray shows the decomposition of the instrumented function latencies. So as we saw in X-Ray, these except initialization and invocation, all the other fields are instrumented by us. So I have a field saying ST and the time taken to run that code is being measured here. Or let's say the time taken to invoke the second function is this lambda trace, which has been instrumented by the user. But let's say if you want to instrument the latencies of the provider, that is not possible because everything is black box for us. Let's say this initialization 1 second, we don't know what all happened, how much was the waiting time or how much was the delay in setting up the virtual machine. So in the afternoon sessions, we will introduce vHive for the full stack performance analysis, not only the user code analysis. So that's all for the session. Thank you guys. And if you have any more questions, I am ready to take.
So there is a question on Zoom. I can read it. So can you give some examples of what additional information for initialization will be available in vHive?
Yes, so we will be using Knative for that. And in Knative, we have a queue of requests. So that queuing time will be visible and the function start time would also be visible. So you will see when, if you attend the trace session, you will be able to see that breakdown.
Yeah, I also can have a comment. Basically, vHive allows you to instrument the provider infrastructure. Provider infrastructure already has some instrumentation. So does much of the network protocols, many of the network protocols like gRPC. So technically, with vHive, you can actually see everything you want to see there. Scheduling, queuing, hands-off, and so on, handshakes.
And if the Knative ones are not enough, you can add another additional hooks there and then monitor anything which you want to.
All right, so please send us your questions on Slack or by email or the way you like it. So I would like to thank Shyam and Frankie to give a speech here. So both of them are in different time zones. So thank you very much for joining.